Okay, sure. So in today's class, we are going to cover dimensionality reduction. Apart from it, we'll also, as we have planned, that we are going to look into SKLearn pre-processing. So I have examples for both. So on that note, let us quickly go through the theory part of it. A lot of this part we have actually talked about it. I think any one of you still remember when we have discussed this?
Yes, we did LDA in R.
When we are actually doing the LDA in R, that time we
Yeah.
have actually thoroughly discussed about the dimensional reduction. We have discussed about discriminant analysis, and we have also talked about what is a supervised answer. Thank you. Thanks a lot, Mahendra. Very good answer. So now coming to, in this session, we are going to cover basically definitely what is dimensionality reduction. We are going to talk about PCA majorly, but I think PCA alone will not help us. So I will also talk about some of the concepts of PCA and IPCA, and there are some other dimensional reduction. Quickly I will go through it, but I will at the same time I will give you the resources so that you can also try practicing it by yourself, and you can reach out to me for any questions. Okay. Similarly, we'll also try to understand about steps that is involved for PCA. We'll try to understand what is factor analysis and steps for factor analysis and differences between the factor analysis and PCA. So this is going to be our learning agenda. So now, basically, dimensionality reduction, why it is required. Anybody will try to talk about it?
When we are doing classification, wherein we have more than two outcomes, then we do dimensionality
So
reduction.
let us try to take it to one more range level above. Basically, in machine learning, the type of data we use that has got a wide dimension, that has got multiple features. We agree on that. So basically, machine learning dimensionality reduction is a process of reducing the number of random variables under considerability by obtaining a set of principal variables. That means when we get a data which has got a large number of features, we have seen the data sets which has got 40 features, 50 features, and going forward, probably if you see the when we are trying to do much more industrial scale application, there will be 200, 300, 400, even sometimes there will be more than thousands features also. But now those features, can we work with all the features, and can we do use all the features, and all the features are basically useful? Many a times we have seen with the features there will be relationship among them also, which you talk about. There means they will be correlated among, there will be multicollinearity in the data. That means they will be related to each other. That also we have seen. Basically, ultimately two variables are contributing to one particular factor. Correct. For example, a sales rep that is visiting, and at the same time probably you are also doing a web ad. Both are actually contributing to what? Your advertisement. So you have a sales rep visit, you have a web advertisement, and you have a advertisement propensity. All three things are basically highly correlated. Agreed?
Yes.
So we can actually take a principal component out of all these things to create one variable, principal variable. That variable, if you are parsing within our model, that will give a better result than individually parsing them. Theoretically, just think theoretically.
Yes.
So this, if you understand this, that is a major concept of it. Now let us see what it is talking about. So it could be also a feature selection or a feature extraction. So what is feature selection? That means using that we are trying to identify which feature is basically in the subset is original variable. That means which is actually contributing to our analysis and which is not contributing, rather confusing our analysis. So it could be a filter strategy, it could be a wrapper strategy, or it could be embedded strategy. Filter strategy, that means it is helping us to identify the core features out of it through filter strategy. Then we are going to feature extraction. It's basically a dimensional reduction process where the initial set of raw variables are reduced to one or more manageable groups. That is a combined feature for processing. This is still accurately, completely describing the original dataset. Ultimately, you will see when you are using a PCA, it is creating some PC quadrants and PC numbers, but ultimately that means principal quadrant numbers, but it is actually describing your datasets and its attribute precisely. Now, where we can use, I have already talked about the concept of the usage. It could be used in step for visualizing the process of high dimensional data, because we are not going to do step by step or probably EDA visualization of each individual features. Rather, we are doing a combined features and we are showing it. And it is still retaining the much of the variance in the dataset as possible. That is a very, very important, that our data, its structure is not getting altered, only we are taking the features and we are creating features out of it. And the dimensional reduction may also appropriate when the variables in a datasets are noisy. There could be thing that I was talking about, the conflicting variables. Some of the variables are actually creating and pulling down your analysis or creating noisy output. In that case, feature reduction, basically dimensional reduction is a good tool or strategy. So if you are going forward, if you are working on a large data set, we will see that if you can use the feature dimensional reduction datasets instead of the whole datasets. Okay. Still now we are good.
Yep.
Sorry, I am actually going a bit faster. Please keep on giving me the feedback, because I want to complete the theory part quickly so that we can go into the codes and explain it in detail. Okay, so now coming into the PCA. Believe me, the PCA, like we have seen in LDA, probably we have to also understand a lot of things in your mind. You have seen that initially we are facing a lot of problem in understanding LDA, correct? Dimensional discriminant analysis also. But then when we have started understanding it in a visually, in a mind-wise plane, then we have started understanding it in a better way. The principal component analysis uses the orthogonal transformation to convert a set of observations. See, use this. You remember we have discussed about the orthogonal transformations and all these parts to set of observation, possibility to correlate variables into a set of values that is linearly uncorrelated variables calls the principal components. That means it is taking the data, correlated variables, and then it's actually creating a linear, basically it is creating a set of values, which is a PCA output for you. And PCA is a method for re-expressing the multivariate data. It allows us to reorient the data so the first of the few dimensions account for as much as transformation possible. That's why you will see that there will be in the PCA, there will be PCA1, PCA2, and all these things. So usually the PCA means first few, like PCA1 to 5, will give you the features and most of the informations possible. And if there is a substantial redundancy present in the dataset, then it might be possible to account for most of the information in the original datasets with relatively small number of dimensions. We are already making it into a 2 by 2, dimension 1 and dimension 2. Now, what is the characteristics of PCA? First, we need to decide how many principal components to retain and maintain a trade between the simplicity. Like when we do a dimension reduction, it will give us probably 1 to 5 PCA quadrants, but we have to see how many we have to keep and what is the manageable size over here. But at the same time, we have to also ensure the completeness. That means all the dimensions are actually captured. That means within those PC quadrants, what are the features that is coming? So is it representing our data completely or not? Then the principal component solution has a property that component is uncorrelated with others, which has the advantage of eliminating multicollinearity. I was actually talking about the multicollinearity. We all understand the multicollinearity, correct?
Yes.
Good. So when using the results of in analysis of dependence. So I will also, Mahendra is giving very good answers today, but at the same time, I will also expect from others to answer. Because I know, because Mahendra has asked a lot of questions during the discriminant analysis, and here he was trying to understand it properly. But at the same time, that time I still remember Achal, Shilpi, Babita, you all were also asking some good questions. So please, if you have still some questions or that concept has become fogged in your mind, please let me know. Okay, coming back, this dimension reduction makes a data analysis for straightforward and manageable. Why? Because you are going to work with comparatively lesser number of PC variables than all your feature variables. Logically agreed?
Yep.
Now, application. It has got actually application, as I have told you, when it comes to an industrial grade machine learning applications. So in almost all the scenarios, we try to apply PCA, especially when I have talked about in those data, when we start with our initial analysis and we see there are those components like multicollinearity, there are all those components like noisy data that is available. So one thing is basically very important. It could be used in finance, marketing, it could be used risk management, it could be also used. Apart from it, it could be also used in life sciences a lot, because if you see, if you are doing like either neural network, before that you are trying to do an data EDA. So some of the, I will not say always PCA, but some of the dimensionality reduction techniques we try to use that. I have some examples for you. I will show it to you also. Very interesting examples like image analysis and all these days we are only working on the data analysis, but now we'll also try to see those examples. Now steps for PCA. First, see, this is a data set. This is a known data set to us. Everybody knows this data set very well. Correct? Iris data sets. Correct. So let us see these iris data sets. So how many features we can see here?
5.
5 features we can see. Great. So there are basically the input variables like sepal, length, width, petal width, and all these things, which is actually contributing to the class of it. Now we can take the input variables like the sepal and petal length and sepal and petal width, and then we can actually apply a PC on that. So how it works? Basically, it computes a mean vector, and in that mean vector, if you go over there, then it actually compute the covariance matrix. After covariance matrix, it basically it measured the 2 dimensions, as I was talking about the 2 PCA dimensions, and then it actually create one of the factors that is known as eigenfactors or corresponding eigenvalues. And here this is the expression of the eigenvalues. Then after that, we try to compute the eigenvectors and corresponding eigenvalues. Then we, in our data sets, now you are seeing that you have seen earlier the data sets, and slowly and gradually your data is actually getting converted into eigenvectors and eigenvalues. And then we use, this is a plot we know. Yesterday also we have looked into this plot. What it is known as scree plot. Basically scree plot, it actually shows the number of ideal principal components we should take over here. Because you remember when we do in the early part of this PC, we have talked how many principal components we should select. So there has to be some rule for it, correct? I told you the initial few will give you the maximum extraction, but what few? What is the number? So if we try to, yesterday we have actually started reading the scree plot. So in this case, so what will be the number of PCAs we should consider?
As per me, 3.
Ideally 1 and 2, because from 3 it is actually forming an elbow. But in some of the cases, yes, we'll take up to 3 also. But you can see the first PCA component is covering almost all of your features, correct? It's very high. You have to read it like this.
Okay,
Then it is called. Then because you can see in 1 and 2, if you see, it is almost covering entire features of your data, all the variants of your data sets, correct?
Yes.
So that is the principle of it. Now after that, we choose components to form a feature vector. Then using that vectors, we actually create a new data sets, and that's it. Theoretically sounds very easy, but when we'll start doing it, we'll try to see what are the complexities involved in that. But theoretically, we have understood the steps.
Yes.
Now coming into the next part, that is factor analysis. So earlier we used to do a lot of this thing in SAS and all, that is factor analysis. So now also we are trying to understand what is because factor analysis also sounds very similar, and there are multiple techniques actually in and around this. But factor analysis is a statistical method to use describe variability among the observed correlated variables in the form of potentially lower number of unobserved variables, that is known as factors. That means from the data we are actually taking out the factors. And the factor analysis approach for such joint variations in response to observed latent variables, we try to understand what are the hidden variables also out of it, and the observed variables are modeled in a linear combination of the potential factor plus error terms. Then factor analysis basically try to find out independent latent variables, like what are the hidden variables in a data that it's try to identify. Then factor analysis uses standardized variables to reduce datasets using the principal component analysis. But factor analysis also use PCA as one of the methods, the most widely used data reduction technique. So now we can see it's something like a factor analysis could be a superset, and PCA could be also be a subset, correct?
Yep.
And what are the type of factor analysis? It could be an exploratory factor analysis, and then it could be confirmatory factor analysis. From the name, from your understanding till now, will you try to contribute, anyone? So what is exploratory and what is confirmatory?
No idea.
Exploratory, wherever this word will come, exploratory, that means we don't have much idea about to start. So in a multivariate statistics, the exploratory analysis or exploratory factor analysis means why we do exploratory analysis even in our data sets. We do EDA, correct? But basically to understand, exactly, to get the key insight. Basically in this case also we are trying to, with exploratory factor analysis, we are trying to understand or uncover which is the structure, what are the hidden, we have talked about the latent set or a hidden set, what are the latent features or hidden features, correct? What are the key contributing factors that we are trying to identify. So EFA is a type of factor analysis which is overreaching goal is to identify the underlying relationship between measured variables. That means if you see marketing data, okay, in our marketing data sets, if you are where there is a sales, so and there are multiple features available, is the ad contributing to your sales, or it is a discount that is contributing to your sales? Getting it?
Yeah.
But confirmatory is something like, then you have already taken in your mind up in and around the idea that that sales were down, so I have given a discount. So and let me try to find it out if discount is driving the sales or still my marketing activities are driving the sales. So now you understood the difference between both the approach.
Yep.
So in statistics, basically confirmatory factor analysis is a special form of factor analysis which is most commonly used in social research. However, it could be used in any of the research. Means social research, why they have mentioned over here, the reason being that social research, we start our researching with a hypothesis, correct?
Yes.
Something like, probably I will give you a social research example, that you are trying to say that TikTok, it's a very hot topic now, correct?
Yeah. TikTok
Now,
versus YouTube.
TikTok versus YouTube, good that you have also gone through this. Now probably some researcher has told TikTok has got a detrimental effect on the mind of youths. So now you have already created your hypothesis, correct? But
Yes.
you need to identify in what way that is coming into the picture. That means what type of behavior is changing. That means it is creating a behavior of social alienation, avoiding the social rules. So these are actually going to be your features, correct?
Yep.
And then you will conduct a survey, correct? And then from those features, you have already seen that detrimental, when you have talked about detrimental effect, you have seen that they are giving a habit that they are disobeying the social rules and trying to deconstruct the framework of the society. So now you are confirming with your data points. Am I confirming? Means hope you are getting what I'm trying to say, or it is too complex?
No, it's okay.
So it is used to state whether the measures of the construct are basically consistent with the researcher's understanding of the nature of the construct or the factor or not. That means you probably with your research you will see that it is actually contributing or not contributing, correct, which will be also contributing to your hypothesis analysis or hypothesis confirmation, correct?
Yep.
So let's move on. Usage of factor analysis. First, again, as we have talked about the subset superset, basically factor analysis could also be used for dimensionality reduction purpose.
Yes.
It could be used for the scale development purpose. Evaluation of psychometric quality of a measure. We have talked about this case study of TikTok, correct?
Yes.
Then an assessment of dimensionality of a set of a variable. We all are good? Still this part?
Yep.
So let's move on. So let us try to see the applications. Applications could be definitely in multiple areas, as I have talked about. It could be used again in marketing, which do factor analysis to identify the factors contributing to the sales and all. Apart from it, in insurance, where the actuarials are actually working. You have heard of these actuarials?
Yes.
You know what they do? Oh, you will be knowing, correct? You will be knowing. It is your domain. Okay. So what actuarial does? Yes.
Actually,
For the class.
Actually, they are the person who create the policies. Actually, okay, what type of policy will work in which area, and what should be the policy amount and all that, and then they do this analysis on depending on the various factor. Most importantly, mortality rate and what infection area on a specific infection rate in a specific area and all that.
So what they do model, they model the life, and they do predict the life related events. That means it could be mortality, it could be disability, it could be death, or it could be permanent disability and those parts, correct? And based on that, they actually, then definitely it's for them the very important factors for a human life. For example, a person is a smoker or not, a person is alcoholic or not, a person is basically has got habits of some social experimentations like what we call as extreme adventure sports, for example, that is paragliding, correct, or probably Formula 1 racing. These are known as adventure sports. Or there is also deep water, deep cave diving. Then there is also sea, they go to sky and skydiving and those type of stuff. So those could be a latent variable. Yes, no, yes, no, yes, no.
Yep.
But at the same time, those people can also be at a higher risk compared to a normal person who is just going to office and coming back home.
Yes.
So now you are getting the concept why it is important.
Yep.
And at the same, with this example, actually, I am also talking about the identification of underlying factor also. Hope that also you have understand. So now you can actually, using this type of thing, you can actually create a group that is high risk versus low risk.
Yes.
Getting it? And then the factor analysis can also help in human resource analysis and their factor and scores. So I think with one example, we have got all the three covers, correct?
Yeah.
Sorry, I'm trying to go faster. Hope everybody, other than Mahendra, because others are awfully silent today. Is it making sense?
Yes, sir.
Okay, thank you. Now steps for factor analysis. So we have seen earlier what we are doing in PCA. Now let us see what we are trying to do in factor analysis. So first, in a factor, what we try to understand, we try to create a correlation matrix. Why it is important? Probably with the step, now you can also start contributing. Why correlation matrix we are creating?
To find out the relationship, multicollinearity.
Absolutely, very good answer. So we are at the same time we are also trying to see what are the factors that is having, what is their extent of contribution. At the same time, what is basically their multicollinearity structure, and at the same time probably we can also understand some of the independent latent variables, correct?
Yes. Yes.
Probably a person, he is neither doing all these extreme things, however he has got a job that for that he need to go into various jungles to collect samples or specimens. That could be a latent variable, correct?
Yeah.
Now coming over here, now what we are trying to do next, we are trying to do extract those factors. For that we are using PCA. However, there could be also other methods, but PCA is the most common method, and other factor extraction methods could also be the maximum likelihood method, principal axis factoring, alpha method, generalized least square method, underweight least square method, and image factoring. So now we are understanding means X factor could be extracted in multiple ways, correct? Maximum likelihood of death in such groups, correct? That could be maximum likelihood method, or maximum likelihood of infections, correct?
Yes.
Then unlike factor analysis, PCA makes the assumption that there is no unique variance, the total variance is equal to the common variance. So that is a one difference that we are getting with factor analysis method and PCA. So in some of the data sets, if this assumption is not getting satisfied, then PCA may not be the suitable or the algorithm for feature extraction. Getting the point?
Yes.
Then recall the variance that could be partitions into common and unique variance. If there are no unique variance, then the common variance can take up the total variance. Additionally, the total variance, if the total variance is 1, then the common variance is equal to the commonality. Again, we are using the same methods like PCA. We are actually looking into the eigenvalue. It's creating the eigenvectors, and then we are actually plotting the spree plot to identify what will be the suitable one. And then, for example, if we look into this, and not Mahendra, any other person, you want to try to explain this pre-plot plot part in the concept of factor analysis, because I know Mahendra has got it properly and I know he will be able to give the perfect answer. So how many factors we will consider in this case? Answer from others, not from Mahendra. And if somebody is not answering within 1 minute, Mahendra will give the answer. And Mahendra, meanwhile you also keep on reading the proper elbow formation here. Okay, it's very very evident here. Others, please.
So 3.
3 will be the answer over here, because in 3 we can see the proper elbow is forming. And in this case, although the first factor is the most important factor, followed by the second and the third, but after that third we can see slowly and gradually it is forming a linear line and it is dying down. Okay,
Yes, sir.
thank you. Good, very good answer, Achal. Now there are also rotational methods we use. So there are basically Quatermass rotation method, then Oblin Coater methods, then Promax rotation methods. But I am not going much details into this because factor analysis itself is a separate topic. So I'm just trying to sensitize the because we are also not going to do the factor analysis. We are only going to do PCA and various PCA related factors. But and factor analysis mostly nowadays, more than factor analysis, we do PCA and we use other methods. So let us not go into much details of it. So now after this, we make a final decision about the number of underlying factors. So now from our discussion, what could be the difference between PCA and FA? I want you now from our discussion, if you have got it, try to answer, means try to explain this, just rather than saying.
सो पीसीए में बेसिकली हम हमारे पूरे डेटा को, यानी कि जितने भी हमारे उसमें वेरिएंस हैं, वेरिएबल्स है, सबको एनालाइज करते हैं। क्योंकि हम क्या करना, पीसीए के थ्रू हम क्या करते हैं, जो हमारे कंपोनेंट हैं उनको रिड्यूस करते हैं डेटा में। एंड फैक्टर एनालिसिस में आई थिंक हम लोग कुछ स्पेसिफिक फैक्टर्स को एनालाइज करते हैं हमारे डेटा का टाइप जानने के लिए, या फिर कि डेटा
and not only analyze करते हैं, you are going in a very good answer you are giving to identify them. Okay, in PCA we are basically taking that, means all the features are going to contribute into your, means basically we are going to take all the features and going to scale it, do a dimensional reduction. But in factor we are also looking into the variance. Okay, and there we are actually trying to identify the latent variables. That is the most important part, correct? And PCA, to use the PCA, the components has to be completely orthogonal to each other. But in factor analysis we have seen that orthogonality is not a must requirement, because there are other ways of also doing factor analysis, correct? I have talked about there are also maximum likelihood and other methods. Then PCA reduce the data into a smaller number of components. That means we have seen that in the PC that it is actually creating the PC factors 1, 2, 3 or 1, 2, correct? Or 1, 2, 3, 4, 5. Then in factor analysis, basically it actually understand what is the underlying data. That means how your data has been constructed. That is importance of the factor analysis. Got it?
Yes, sir.
So we understood what is the similarity and dissimilarity and relationship of PC and factor analysis.
Yes, sir.
Okay, I'm really very happy because this much of component we have covered within half an hour. Otherwise this itself should have taken almost 2 hours today, which I do not want. Okay, for example, if we see it visually, you can see these are the y1, y2, y3. What are these y1, y2, y3 and y4?
Variables.
What is, these are variables of features. Very good answer. Who has given? Bobita, I think, correct? Or Anshul?
Sir, Babita.
Okay, Bobita, good. And then we are actually looking at it. What is what W1, W2, W3 and W4? They are various weights of it. Now it is actually considering the features and their actual weightage to create this component or the PC component, that is C. You are understanding it?
Yes.
I think this is the very easy understanding visualization of all the long talks we are speaking about the PCA. Basically what PCA is doing, PCA is combining four variables into a single PC component, that is C. Okay, in principal component analysis, the components are calculated as a linear combination of the original variables. So now what we can see in that way, basically our no features are getting missed. So that is the thing we are keep on talking about PCA, because your all the features according to its weightage, it's coming into your component C. We are clear?
Yes, sir.
But in factor analysis, what we are doing here, you can see basically in factor analysis again our features are y1, y2, y3 and y4, correct?
Yes.
And there is also random error related to it, that is u1, u2, u3 and u4. So here we are actually considering the one factor and we are actually breaking it down. So that's why you are getting basically what we are analyzing here, that our y1 is related to basically b1, which is a factor loading factor. It's known as loading factor. And then f is a factor, and it is also combined of error. So each of
So
your
loading factor क्या है?
So loading factors are basically, these are the factors which actually constitutes your particular variable, because like in this particular case you have seen there are weightage, in this continuous, there are basically considered of loading factors we call. So for example, your one of the factors P1, it could be 1, it could be here, it could be around 3.5, it could be 4.5, and it could be 5.5. And that loading factor, we actually get it from the factor analysis. That because of what are the loading factor, because I'll just show it to you. This is actually, we used to do this using SPSS. So this will actually help you. So you can see here, each of your contributors are coming. I'm talking about this one. So these are actually going to be your loading factor. So it will analyze your data and it will provide us the loading factors for each of your variable. So ultimately, your data will be constituted of the loading factors. Hope are you getting it, or am I able to explain it, or so you can see it from here? So these are each one are basically one questions. So where initially we are thinking that each are going to have the same range. However, post extraction, we can see the loading factor for each are actually going to vary. That you can see. Now within this, again, this is basically a principal component, but here you can see your factors are within the PC1, it's covering majority of your factors, and PC2 is actually coming from this, and PC3 is covering all these all factors, and PC4 is covering all of these factors. Correct? So these are going to be your loading factors.
Okay.
Got it, Anchal? Mahendra, you got it?
I think yes.
What about Anchal?
थोड़ा बहुत समझ में आया, प्लीज ये लिंक शेयर कर दीजिए, मैं एक बार इसको प्रॉपर से क्लास के बाद देख लूंगी.
Actually, this is this factor analysis I told you now we used to do in SAS and SPSS. This is an SPSS tutorial. Sure. Okay, I will share this after the class. Now, hold on. Okay. So in PCA, we have given the weightage to get out your PC number, but in this case, we have used the PCA to get your this factor loading number. That you got it? And then we are going to construct. So in the factor analysis, the original variables are defined as linear combination of the factors. Got it? So
Yes.
now, on that note, let us look into PCA. We'll start understanding, although factor analysis, we are not going to do any exercise or something, but we are going to work on PCA. For that reason, let me close some of the, give me 1 minute. I want you to open a few more things, which I'm going to paste for you. Please open up this. Open up this one. Okay, and now go to this Python stats, and under that you just download this dimension reduction. Okay. Meanwhile, I will also share with you just tell me all your email. I can just share it with you. Achal is there. Mahendra. And Shilpi. Correct? You just copy it. Do not edit it. Just copy it. Please let me know if you have received it. We'll start doing it together. Please let me know once you have received this. All of you have received the dataset?
सर जो डायमेंशन रिडक्शन के अंदर है वही है ना?
No, I have shared that you can that we will that is a class study. We'll do that. Okay, we'll go into that class study. But before that, we are actually
जहाँ पे R और Python का फोल्डर है ना, वहाँ पे गूगल कोलैब का सर का पड़ा है, मुझे मिल गया.
और share with
No.
me के साथ
No, have you
डायरेक्टली
got this?
शेयर विद मी में देखो, वहां पे तुम्हें मिल जाएगा।
principal concept analysis वाला
Principal component analysis, yes.
sorry principal component analysis
Okay, so what you will do once you get it, copy it. Create your own version of it. Just copy it. Okay. Then I will change this thing as a to who has completed. I will just make them.
सो मेरा हो गया।
You have copied it.
यस सर।
Then your name will change as a principal component analysis copy or something like that. Correct?
यस।
What about others, Mahindra?
Doing.
copy in drive
Hilpi?
हेलो सर। नहीं सर, मुझे अभी तक लोकेशन नहीं मिला उसका।
You will get a notification of you under your Google Drive. There will be a collab folder. You will get that also over there. If you are not able to get not at all able to get it over from, and then copy it in your system, make a copy of it. Okay.
Okay sir, I got it.
Everybody, so let us try to step by step understand what is PCA.
सर हेलो।
Yes.
सर एक्चुअली कल भी आप करवा रहे थे ना, मेरा कल माइक का थोड़ा इशू था। सर मुझे ना जैसे इसको जब मैं माउंट करती हूँ अपनी ड्राइव से, सर मुझे ना वो लोकेशन डालने में बहुत प्रॉब्लम होती है। मतलब मुझे 3-4 बार ट्राई करना पड़ता है उसको प्रॉपर्ली, तब जाकर वो पता है, अदरवाइज एरर भी शो करता है।
Okay, then I need to check it, but not now. I will probably check it, take out some time and check it, because today we have got lot of things to cover. This then we have to do one case study, then we have to do other things. Okay.
Okay sir.
That is the reason I don't want. I also don't want you to code right now. I just want you to understand and run the code.
Okay sir. Okay sir.
We all are good now.
yes sir
Yes sir.
Okay. So on that note, let's start running. So we are loading our libraries. So while loading the libraries, let us try to understand what we understood still now. Principal component analysis. It basically what type of algorithm it is? Supervised or unsupervised?
सर सुपरवाइज।
Who has told supervised?
अच्छा मैं साथ।
Hey, why it is supervised? Then you have to tell. Are you sure it is supervised? Very fundamental thing. And Bobita, why it is unsupervised? रट्टा मारने से काम नहीं चलेगा, सिंपल से अंडरस्टैंडिंग करना पड़ेगा। एक चीज समझो, लॉजिक। Please go ahead.
It is unsupervised because system is creating the
PC quadrants.
classes. Yeah, he is creating the components.
We are not instructing it to create some certain number of components out of it, or we are not actually driving it to get certain type of components out of it. Rather, what we are trying to tell over here, that this is the data. I need a dimensional reduction. So that is the reason, based on some algorithm, the dimension will get reduced. So it is unsupervised technique. Okay, so it is one of the most broadly used unsupervised algorithm. It's fundamentally a dimension reduction algorithm, but it can also be useful tool for visualization, for noisy filtering, feature extraction, engineering, and much more. We have already discussed about that, correct? So now let us see. It's basically a dummy example. So where basically what we are trying to understand from here. So let us try to take a dummy data X. So what is the data X here?
Where is data?
It is a dummy data, correct? It's any random dummy data, correct?
Yes.
Now, if we try to see that data in a scatter plot, so this is our data, correct? So we can see in the there are two variables we have seen in that X data, and visually from this scatter plot also we can see that there is a almost nearly linear relationship between the X and Y, because if we draw a line, it will show a linear relationship, correct?
Yes.
So now we will try to see, using the principal component analysis, the relationship we'll try to quantify with the principal axis. So that will give you a small understanding how this actually works. Okay, for that what we are doing, so all of these features I have already given you a link. It is available under basically this particular area. Just 1 minute, it's open somewhere here. It's available under sklearn decomposition. Okay, so what is sklearn decomposition? Sklearn decomposition is basically a module which provides you basically the matrix decomposition algorithm, including most other than PCA, NMF, ICA. You can also see there is a factor analysis technique also there. There is also fast ICA, that is independent component analysis, because there are multiple algorithms actually come under this decomposition. I am not going to talk about all of them, and their applications are also in diverse areas. Some I will try to quickly open and see, but at the same time in PCA also there are multiple PCA types which I am going to show it to you. Okay, so how we are going to call it? So from sklearn dot decomposition, that is our library. From there we are importing PCA. Then once we are getting PCA, then we are actually going to look. Now yesterday we have learned this. What is this? This is the same structure across sklearn. If you once you learn this, it will be very easy for you. Anybody recalls till now? Yesterday Mahendra has got a very good answers. Even Achal has also given good answer. Bhavita has given good answers around this area. What is this? N components. What is N name in? What is N components?
Parameter.
सर n के
all-
पैरामीटर्स निकाल दीजिए
नजदीक पहुंच गए हो, पूरा मतलब टारगेट को बुल से नहीं कर पाए. These all are known as not parameters. These are known as hyperparameters.
okay
Always. So when in going forward, you will actually see that people are talking.
एक्चुअली मैं वो इसको सोच रही थी लाइक कि जैसे हम के मीन में वो दे रहे थे ना कि
मैं
हमारा
भी
कि नंबर 2 3 ये तो मुझे समझ में आता है कि हाइपो पैरामीटर्स है, क्योंकि ये हम नहीं भूलने वाले. बट मैं कंफ्यूज हुई, हम के मीन में उसको बता रहे थे कि नंबर कितने नंबर वो होंगे हमारे 2 3 एल्बो देख के, तो मुझे लगा ये सेम चीज है.
यहाँ पे भी हम लोग वही तरीका यूज करेंगे, don't worry. But at the same time, let us look into the hyperparameter structures. So that's why I have given you this link. So what are the hyperparameters? Without this, you will not able to understand. You will see it will look like a code. But when you are doing it, I want you to basically change some of the components and run some of the components and see how the results is getting changes. So what are the hyperparameters are there in PCA?
n component copy Content, global,
So n components is basically saying that number of components to keep. Okay.
yes,
So in
sir.
this case, I have kept it true, 2. But at the same time, what is the default comes? It is none.
None.
Okay. By default, it is none. Then copy true, y10, and all these parameters you can also understand. So these also we have to read, and believe me, you will not be able to remember all of this. Nobody can. Correct. So it will be always good, the particular model you are doing, whenever you are doing, first go to sklearn, open this, and I also keep on doing this. So it's, I'm just sharing my best practices with you, if that is helpful. Correct. Because it every time you will not be, or else what you can do, if you can actually first, if you do not remember it, what you can do, what are the by default, this is a method for that. Now you can see, if you run like this, what it is giving you,
Iteration power object and component 1. By
that
default,
means what it's giving you, all the hyperparameters by default. So if you are writing anything, so what you can do means, I'm just sharing my secret sauce with you, so if that helps. So basically what I do it like this. I open sklearn, or I do it like this, and then if some of the parameters, if I'm not able to recall its activity, then I can actually go and refer to this document, and accordingly I optimize. Make sense? Helpful?
Yes, sir.
Bobita, you were trying to tell something, I was not able to hear.
No, sir.
Oh, means you told that that is helpful, or means I have not understood it basically.
Yes, sir, it is helpful.
Okay. Okay. So now you can see. And then what we are trying to do, we are actually now with this, we have got our PCA. In PCA, what we know that it actually creates the PCA components. So let us print the PCA components. What are the explain variables? We can actually create the explain variables. Then actually, if we try to visualize it, we can actually visualize through this particular plot. You all are getting it? And it is a 2x2 PC components. Now, we have also talked about the orthogonal plane. Now you can see all of these components are basically, now this is your original input data. It in this principal component is actually getting distributed within an orthogonal plane, component 1 and component 2. You're understanding it? That means these two features means your two features which is there in the data, it's actually getting distributed. Similarly, if you do it on a large data set, you will also see it will also get distributed in a orthogonal plane within the PC components. So let us try to see that. Okay. So next going to be an example where we are trying to see how it is used for dimensional reduction. So it has actually helped the dimensional reduction or not, that we can get here. So what was the original shape? 200 data points into 2 columns, correct? Now transform shape with PC, everything has been fitted into a PC component 1. So it has what has become into transform shape, that is 200 into 1. Making sense? So now our entire transform data has been reduced to a single dimension. If you want, we can actually perform an inverse of it also. So now you can see this was your original data and this is your PC component. Got it? The theoretically got the concept of PCA, how it helps in data. Visually, we have seen how it actually creates the dimension reduction.
Yes.
But at the same time, we have seen that one thing, that it has kept the original structure of the data, but at the same time it has extracted a relationship that is almost linear relationship.
Yes.
So now we will perform this. Why I'm actually doing it in Colab, there is a reason behind that, because now there is a dataset by name Amnest, which is we used as a basic data for deep learning. It's a heavy data, so it's the same data that is basically which is basically handwritten digits. So these are basically carry the this Amnest datasets. The datasets come like this. Okay. So these are what? These are handwritten digits. We are going to use the same technique on this data. And this data, yesterday we have talked about that some of the datasets are also available within sklearn. So these datasets are available under sklearn, a portion, not the whole data, a portion of the data which is available under digits. Okay, so it's known as load digits. So we are loading that data. So what is the dimension of the data? If you see
by 64 variables, 1797 rows.
1797. So you can see it's a huge data.
Yep.
And because it is basically all the data set is available under image. Okay, so the data sets, and it is basically 8 into 8 pixel images. So that's why 8 and 8 pixel images are contributing to this 64. Okay, so there could be 64 dimensions. Getting it?
Yes.
Now probably we are going into much more complex data structures. Now all of this using PCA, we are trying to create that 64 dimensions. We are trying to reduce. So what we are trying to do here in the next code,
reducing it to 2.
so our data is remaining constant. However, these 64 dimensions we are actually trying to reduce into 2. Let's do that. You are also doing it parallelly, correct?
Yes.
Now if we try to put a particular scatter plot of this to see, and this scatter plot is basically the PC1 and PC2 component. You can see some of the features are much more closer to component 1 and some of the features are much more closer to component 2. You are getting it? This is coming. Again. You can see how many colors you can see. There are, you can see the multiple colors, but some of the color clouds are coming closer to component 1 and some of the color clouds are coming more closer to component 2. That means, you remember I was showing this spaces table where it was talking about some of the factors are contributing towards principal component 1 and some of the factors are contributing towards factor 2. So here also some of the features are contributing much towards component 1 and some of the features contributing towards component 2. And some of the features are distributed across. So if you see, the full data is basically 64 dimensional point cloud, correct? Where these points of projections of this data, now if we are saying into 2 by 2 matrix, this is a 2 by 2 matrix. Some of the variable points or dimension points are closer to some of the component, and some are closer to the another component. Now it's something like a huge data set, 64 dimensions you are trying to squeeze in into 2x2 matrix. You are getting it?
Yes.
So now what are basically those components mean? Like, you remember we have actually talked about this in our slides also. The same slide, same how it is looking like. Just one. I think I have closed it.
Weightage and
The last slide.
just a weightage and y1,
Weightage and
y1, y2, y3 variable components. Variables.
here also, absolutely. Thank you, Bobby. A very good answer. So now here also you can see x1, x2, and these are weightage, and pixel 1 and pixel 2. These are actually going to be your variable components. Now each pixel actually in a handwritten digit, each pixel actually contributes to some of the portions. Correct. Now instead of pixel, just imagine this is your face or my face. Correct. So some of the components are actually going to talk about ear, some of the components are going to talk about nose, some of the components are going to talk about lips. Correct. Think theoretically. Getting it?
Yeah.
And some of these components actually, if you are trying to use the same PCA technique to identify, just now you open up your imagination. I have given you a large data set where there are humans, where there are animals, and where there are flowers and all. And now I told you to identify humans out of it or dogs out of it, theoretically. So these, all the pixels components are going to be some features.
Yes.
Getting it? So which is contributing to the identification procedure, and you are actually trying to reduce the dimension from large to small. Now hope that makes sense to you. Okay. Now what is the basic choosing the number of components? So what is the choosing the number of components we have talked about? So a vital part of PCA is definitely how many components are needed to describe the data. This can be determined by looking into a cumulative explained variance ratio. So this is a thing I have not talked much about. So it actually talks about how many components are there, because this is a large data. Let us run this. So what it is talking about, you can see now slowly and gradually after 40 and all, it has become a bit saturated. Correct?
Yes, sir.
Yes.
So what it is talking about, that means it is talking about the digits that has got a first 10 components explains only the 10 components explain how much? Above 75%.
Yes.
20 explains above
Almost 90.
almost 90%. 30 reaches to around
98, 97.
98. 40 almost explain around
100.
100%.
100%. So that will give you an idea how much of the data is basically explaining how many variances components or the variances are actually explaining your data. This is useful.
Yes.
Now we are actually out of the complex theory, we are actually making much more sense out of it. Now it could also be used as a noise filter. Okay, we have actually talked about in PCA at the beginning, the application there will be noisy data, and which can also be used for the noise filtering. Correct?
Yep.
Because there could be a chance that some part of the data which is basically some variance is a larger effect, because it also in PCA it also goes by weightage. So if we construct the data using the largest subset of principal components, we should preferentially keeping the single and throwing out the noise. So if in this case the PC1, probably if it is considering the maximum component out of the data, then if you are using that as an input, we can actually throw out a lot of noises. Just wrap around your head. Let me have some water. You got it? What I am trying to tell. So let us try to see. So this is our original data sets. And now let us try to create some random seeds of noise in this data. Basically, we are trying to distorting the pixelation here. Correct?
Yep.
That's why it means probably if this is like, if any one of you are liking this a lot, then probably deep learning is going to be much more interesting thing for you. Are you liking it?
Yes, sir.
Now see, this was your original datasets, handwritten datasets. Now once we have introduced some of the noises, so is it, if you see the previous one and this one, which one is better readable?
Previous one.
Previous one, because we have actually created noises. So what has actually done by these noises, because it has actually added some random pixelations into this. See, what is random noise in a pixelated data? Basically, we have added some random pixelation into this. By this, it's actually distorting our data sets. It has become much more noisy. Correct?
Yes, sir.
So now, if we actually create in this data, it's not very much possible in a naked eye just to identify means how much distortion has happened and how much noise has come. And so now if we try to use some algorithms, it will help us to clear the noise out of it, and it should also help us to explain and preserve the original variance. So what we are doing, we are with PCA, we are trying to see here, what we are doing, we are trying to do, we are telling that it should at least take the 50% of the our projection is basically that we should try to preserve the 50% of the variance, and the fit is talking about noisy. So for that, how many principal components we have to consider is 12. Now, for example, if we try to create here, instead of 50%, if we try to go here 80%, so how many principal components are required? You can see 37. If you try to go around 59, so now you have got the concepts why it is 50. And similarly, you have also understood the fit, why you have used the fit as noisy, because we know that this data is particularly distorted. Got it?
Yes, sir.
So here, with this example, we can see the 50% of the variances actually amounts to 12 components. Similarly, we have seen when we have put it 97, I think it has gone to 59, correct? Anybody can just quickly do that.
90.
97. Make it 97.
59 ही था.
59 था
59
ना?
था. Yes,
Yeah,
sir.
because I recall it. Thank you. Thank you. Now, this is actually creating a lot more obstacle today. एक मिनट में इसको ऊपर ले लेता हूँ. Now, we are trying to use our transform data, which we have used through PCA, and we can see this is far more better.
Yes.
So hence we have proven that if you have a noisy data, to identify the proper data and the features, PCA could also be a very good feature selection method we can apply. Agreed? And that's
Yes,
we
sir.
have proven strongly using this very large dimensional data. Correct?
Yeah.
Now, in the class, I mean, in the hello? Somebody is trying to tell something?
Also,
No, sir.
Okay. Now we will actually try to get another data set. Again, we are going to get it from sklearn datasets. Okay. Run it. It will take some time. It's again a large data. And here we are actually going to use an advanced method because see, I cannot do deep learning, but at least there are some equivalent deep learning methods for you, like support, which is SVM, support vector machines, that we are going to use. And this dataset we are going to use, it's known as wild dataset, which actually take out the face of some of the key people of the world. Okay, and this is a data that came around 2008-9. So that time George W. Bush, then Rumsfeld, Hugo Chavez, Tony Blair, these are the names. Sounds familiar to you?
Yes.
yes, sir.
They were basically the country leaders of various countries. So what is this data set? It actually looks, and now earlier what is the dimensionality we have looked into? So now in this data, let us try to understand about the dimension. Here the data set has got a dimensionality of nearly 3000. How to understand that? Here we have seen it is basically a pixelated 8 into 8 images, correct? 8 into 8 pixelations. So in these particular cases, it is going to be, although it's not a colored image, but it is not fully black and white also. So that is the reason it has got almost 3000 of dimension. It's a very high dimension data. 3000 dimension it has got. Got it? So even it's just
सर
FYI
सॉरी
was
मैंने शायद मिस किया आपने ये मतलब आपने डायमेंशनलिटी चेक कहाँ किया मतलब कैसे पता चला आपको ऑफ नियरली 3000
Observations multiplied by variables. Simple.
ओके
and यहाँ पे कितना dimensions था? It's 8 into 8 pixelations, correct? That's why it was having 64, because when you look into this, I have talked about it's a 8 by somewhere I have actually see. I definitely have talked about it. Otherwise, okay. Correct. Here I have taken it out, and I have told you the reasons behind, because that data consisted 8 into 8 pixel images. That means 64 dimension.
ठीक है मैंने शायद मिस कर दिया था ये
इसका ठीक है, तो हम लोग यहाँ पे देख लेते हैं ना. So here what we can see, the dimension is nearly 3000. So now out of this, let us try to take the first 150 components. How to do that? And here we are actually going to do it with randomize, because here we are not going, because it's a large data set, correct? We cannot provide a bias selection. So we have to do a randomized selection. So that is the reason you have to write this randomized PCA. Earlier this writing method was different, but now if you want to, earlier there was from SK decomposition directly we used to import randomized PCA, but now this method of randomized PCA has been deprecated. So if you want to write this, because if you write it directly, this sklearn decomposition import randomized PCA, it will give you error. But now first what you have to give, you have to take the PCA as randomized PCA, then it will work out. Okay,
Yes, sir.
Let us run this. Again, in n component, we are giving 150. That means we are actually going to look into it's randomized, and we are going to look into the first 150 components. Got it?
Yes.
Yes.
Now, what we are going to do using our principal components, let us try to. So in this particular case, it's a very complex eigenvectors. It is not a numerical eigenvectors, but it has actually taken in the form of pixelation. Let us try to visualize it. So now you can see, but if it is a numerical variable, if you are using, you will get the numerical eigenvectors. But in this case, we have got the faces. Correct? Now, what we can see, can you identify some of the person from here? George Bush. You can identify him. Few more probably will come, and who has come, that we'll see later. Now again, how much of explained variable is getting explained? Let us try to see. So somebody explain this for me.
It's going till 90% only. We are not. So one is the topmost line.
So basically, if you are taking around 150 components, it is covering almost 90% of the variance. Correct? Like for example, if you go here and if you make it oh, sorry. So how much we are covering in this particular case? If you have made it 100, 100 means we are actually
More than
covering
92%.
92%. So if you go here and make it random as so you have
Still
made
98.
till around 98. That is the reason we have make it around 150, because 150 is covering around 95% or 90, 92, 93%. Okay. Let us bring it back to 150. इंटरेस्टिंग लग रहा है गाइस या बोरिंग लग रहा है?
No, it's good.
That is the reason I thought that I will just give. Now what we have seen that 150 components is basically accounting all more than 90%. It's 92% actually. So these 150 components, if you are actually modeling, it can recover most of the essential characteristics from the data. Correct? To make it more concrete, probably if you want, you can, instead of that, you can also make it 200. That is your choice, or probably make it 230, 250. Now using that, let us try to recreate the faces. So now we can see out of this, basically the top row shows the input images, while the bottom row shows the reconstruct of the images out of 150. That means it has taken out the data and it has reconstructed the face. it's almost proper. Like in Bush, George W. Bush, we can see at least few cases it is coming proper. Dalai Lama also you can see it is coming, some of the cases it's proper, correct? Hugo Chavez, this one is a bit distorted, but somehow it has still captured it. You're getting it, correct?
Yes.
Yes.
So that is the one of the application of principal component analysis. So this is available with you. Read it, play around with it. Okay, but now with this, we will actually start doing one case study. Make sense, guys? So for the case study, what we'll do, we will use this problem statement. So we have got these datasets, that is a house datasets, correct?
Yes.
Let us load it and let us try to apply some of the characteristics of it. कहाँ पे करना है, लोकल, जुपिटर या दिस में?
एक ही बात है.
So let us load the data. I have already given you the data. Meanwhile, start loading the data. And meanwhile, let me also quickly set it up in Google Colab. Upload कर रहे हो ना? You are also loading it, correct? So what is the dimension of the data? Have you
1460
loaded
by
it?
81. Yes.
81. Let us perform a quick EDA on our data. So let us try to complete it within half an hour. So ekdam matlab we'll do it very fast. Okay, quickly, so that so these are the columns that is available.
We can see shape.
Shape also.
Yeah.
So now in terms of shape, let us see the more details around the shape. So there are number of numerical variables are basically 38, but there are 43 categorical variable also. So next we are going to do check for correlation so that we can get the concepts of multicollinearity. So you can see also there are some data points could have a bit of multicollinearity. You can see the numbers like 82, 83, 82, 83,
79, 64.
79, 64 is still okay, but more than 83 and all these things. So they are highly correlated. We remember how to we have made this means we still recall our reading this correlation matrix.
Yes.
Then this was our predictor, correct? Price selling means what is the selling price?
Yes.
Now it's like
Slightly skewed.
slightly skewed. It's positively skewed. So that means that also actually talks about there are some houses which is very highly expensive. Most of the data remains within this range, but some actually expensive houses. So what is this is providing to us? That
Sale price versus house quality.
overall quality that actually talks about the overall quality is one of the predictor of higher prices, correct? We can see,
Yes.
although not very, to some extent, it is indicative of, we can say. Similarly, the construction year is
So,
also to some
yes, newly built house contribute more in sale price.
more in the sale price. Similarly, ground living area. So there is a trend, definitely we can see.
If living area is high, then price is also high in some extent.
हमने इस डेटा पे पहले भी काम किया हुआ है ना, आई थिंक लीनियर रिग्रेशन के लिए आर में.
Yes. This is a data we have worked.
बोला आपने.
California house pricing.
यस सर.
Good. I was expecting. We can see a trend, but at the same time, there are a lot of outliers also. Correct?
Yes, sir.
Please keep on. Means, if you are getting any interesting observations like this, keep on saying that. Then that also I will understand that we all are understanding about the data in a similar way. So you can see the concrete houses basically drives much more price compared to others. Correct?
Yep.
Although there are outliers also.
But we will not remove these outliers because these are due to some other factors, right?
Yes. In this case, will not do anything right now.
Yeah.
Still, we have not looked into the missing data. That means our pre-processing is not completed. Correct?
Yes. And I think we should remove that first column also, ID.
Yeah, that we can drop. Pool has got maximum missing data followed. All lot of
So there are a lot of variables with missing value. So we are going to treat the missing value for the variables which has the higher value for the correlation with the sale price, like pool quality, miscellaneous feature, allied fence, and
Yes.
fireplace. Or we are going
Yes.
to treat it for all the variables.
No, we'll do it only for the where there is a higher correlation. Even you remember this is a thing same way. Even while doing in R also we have done in similar way. We have looked into one by one.
Then we have only 5 variables which we need to treat.
Yes. So what are those? You tell me.
First is pool quality, which is
Okay.
done. Then miscellaneous feature done. Then alley, okay. Then fence,
Then alley, then fence.
and then we have fireplace. QU means quality होगा, fireplace quality.
So I have already completed 3 of them. 2 more to go.
Now fence.
Similarly, some of the numerical variable has also got this, as like this slot front gate.
Not front gate.
Garage.
These are not highly related, but yes, missing values are there.
Suppose there is garage or no garage, like type of thing. Similarly for basement, also basement or no basement. Actually, initially I thought that I will show you the pre-processing, then I will come over here, because here we are actually doing a lot of pre-processing. So if you have any questions regarding the pre-processing, let us hold that. We will take it out with the pre-processing. Okay, like
Okay.
label encoding and all of these things. We have reached till this. Ultimately, after all this processing, our data has now become with 222 features. What about Achal, Bhavita, Shilpi?
We are doing.
You're doing it?
Yes, sir.
Madam Shilpi and Madam Achal?
I'm also doing, sir.
Okay.
Yes, sir.
Okay, I have done till this point.
So you have
So
got
here,
the
either we should remove this ID column or we should make it as index. Convert it in index.
we can actually drop, that we can actually drop, convert as an index. Or when we are writing the PCA, probably we will select it from that next to ID, all the columns. Okay.
Okay. But if we remove, then it will be better for the system to calculate things, because it will be easier for him, because otherwise he will go by this column as well by doing all the classification and all that.
Yeah,
So
we have
should
to.
remove it.
We have to remove.
Because it is also increasing the dimensionality.
Even also we have to also remove the
Sale price.
sale price target variables.
Yeah.
I have done that. What you have told.
Now to the columns.
Now we will do the standardization. first way of what we are doing here, the way we have discussed in our theory, we are actually going to look into it step by step. So how much you have progressed?
Maybe 1 minute only.
You are here. You are with
I'm on step 5. Select components based on eigenvalue.
eigenvalues. Okay. So now you are seeing the plot. What I was trying to show you. You are actually understanding the basis of it also. Correct.
Yep.
I have earlier shown you in a visual way. Now you are understanding the basic, just a mathematical base of that.
Okay, I reached to this point.
So what it is showing to you, how much of values it is explaining. It's almost creating an elbow. It in between it is dropping, but
Yes.
it's almost. And this type of scenario could also be misleading also.
Yes. Because there is no clear elbow.
This clear elbow, exactly. Dataset explain variance plot you have reached.
Yes. Now reached.
So
So
now
here
that
it
is
is saying that 150 we are covering more than 90%,
more than
almost
90,
95, 94%.
almost 90, 92, 93%. I
Yep.
think this is 90, 92, 93%. Okay. But now I think we are actually in the same page. What about others?
Yes, sir, I am there.
Okay, it's 96%. So visually I was actually telling wrong.
Okay.
Then in how much it is explaining in 155. It's a marginal change, you were saying?
Marginal, yes. No, but we are reaching to 97% almost.
Almost 9. No, even if you see, if you say it is in 099, so if you, okay, it will be 91%. Huh? So now if you see, well, it will slow down. Let me see. 200, it is going to 100%.
Keep it 160, 160. At 160, it will be 97%.
Mm.
That's better.
160,
More than
more than
97.6.
more than 97.
So we are going forward with this 150 or 160.
So we'll go forward with 150 only.
Okay.
So that was a step-by-step PCA. Now we will do using sklearn or sklearn libraries you loaded. Now we actually, while doing this, you will also appreciate why somebody has come up with sklearn. So many steps we have done. It's getting done in some 3-4 lines.
डिस्कनेक्ट हो गया
Indent issue for count plus 1 after if.
That's why even I also pay for collab. You can see why it will actually take you to the exact index. See, it is smooth, correct?
Yep.
No issues. Okay, once it is done, I think it will give. So at 155, it is actually explaining almost 90 same answer what we have got earlier.
Yeah.
So finally, we have done dimensional reduction using PCA. Everyone is through? Hello, Mahendra?
Yes, I'm done.
Okay.
I'm also done, sir.
Okay. Let me wait for some 2-3 minutes more. Then we'll go and show you the other examples. But what was it interesting? Today's both the things?
Yes.
Similarly, I wanted to show it to you some other PCA. I think today we might not get the pre-processing entire thing, but I have already prepared it. Or let me see. Let us see how much we can cover. So Shilpi, others, Shilpi and Bobita, I think.
Sir, almost done. Hello, sir.
Yes. You are done?
Okay. Sir, I thought yes, sir, I'm done, sir. I thought कि शायद मेरे को voice नहीं आ रही इसलिए.
Okay. Okay. Sure. Thank you for confirmation. So now if so now similarly there is one more example I wanted to show it to you. So what you can do, you can open your own Colab. Similarly, it is one of the examples from our iris dataset. We have seen the class example, what we have discussed. It is the exact same plot of that. Similarly, there is an interesting concept which is basically a large data. There is something known as incremental PCA. Have you got the link? Hello?
Yes, sir.
So incremental PCA is a method which is used as an alternative to the traditional PCA method. When we use basically incremental PCA, because we have seen sometimes the databases could be so huge that it will not fit in probably in a memory properly. So in that case, it goes in a step-by-step fashion. So basically, IPCA or incremental PCA builds low rank approximation for the input data using a memory, and it gives a similar output like PCA. So this IPCA technique also you can use as an alternative to PCA. And to initiate that, this is the key line where first we are importing PCA, from there we are loading the incremental PCA, then it goes into a similar way. So what you can do in the same data where we have used PCA, you can also try and use incremental PCA and you can see the output. Got it? It will give you the similar output. Apart from it, there is also sparse PCA. Similarly, there is also mini batch sparse PCA. These are the various variations of PCA. Under Escalon. Then This is an interesting, again, dimensional reduction that is known as latent dialect allocation. This we use basically for the text data. If we are doing some text analytics example, there we can use this latent dialect allocation. Then there is also KPCA or kernel PCA. Only thing here, all the parameters will basically get changes. Like we have walked into the digit data, correct?
Yes.
So same digit data, I'm actually showing you an example of kernel PCA. So what was the dimension in digit data?
Don't remember.
Anybody still? It was 64 into 64, correct?
64 into 64 or 8 by 8 total 64.
Sorry, 8. Sorry. 8 into 8 is 64. Sorry, you're correct.
64.
My bad. So now with this, you can see it. We can reduce it to 7 using kernel PCA. These are much more advanced methods. You can see some of the examples of kernel PC. So it's a particular datasets, again, by name make circles datasets. The same example which I have shown you for our clustering also, the same date. So it's, you can also see IPC is also giving you the similar result. So these are all alternatives of PCA for you. I'm going to use IPCA. Then we need a linear diameter regression. Similarly, we're going to use KPCA example also. Okay, so let me share this also with you. These are the other variants of PCA. If you want, you can actually some of IPCA you can use in the same dataset and the same use case what we have used. You can use and see what is the variation you are getting in the outcome and all. You can do that. So you're good still now?
Yep.
So shall we just quickly start with this one, sklearn preprocessing, because I have just kept a small case study on that. I'm also sharing with you. This is done. I'm closing this. This I'm sharing with you. Please let me know if you have received this. Meanwhile, let me just share this preprocessing document link also with you. Okay, so what we understand by preprocessing? Quickly, because we don't have much time. 9 to 10.
Getting our data ready for the further processing.
Basically, in preprocessing, we try to, because the data what we get, it's also known as data messaging or data cleaning or getting the data ready for analysis. You are absolutely correct. So we do various things, correct? We do data standardization, data scaling, mean removal. We also perform NA updating. We also perform means feature scaling. Those all parts actually are part of this module. which is known as pre-processing. For example, I am just starting. If you just open it up, okay. So sklearn, that is simply this scikit-learn has actually yeah, this error keep on coming. I don't know why. Okay. So for example, I will show you. Let us try to take one NP array, that is NumPy array. Okay. In this NumPy array, we are actually trying to do a standardization or mean removal function with it. So you can quickly go here and first let me load the array. And using this pre-processing scale function, you can actually do the scaling of that NumPy array. Similar way, if you look into the missing value handling, we have looked into the missing value handling during our NumPy in detailed way. So if I just put these data sets, it's a NumPy array. So we can see there are lot many NaNs are coming, correct? So those NaNs we can actually handle in multiple ways. And similarly, in sklearn, there is a impute import missing indicator that can actually provide you where the missing value is, and you can perform various imputation techniques on that. So to understand it more, I have actually taken one small case study. So load it. So that particular data I have loaded under if you go under pre-processing, there is a data for pre-processing, correct?
Yes, sir.
Please load all of these files. So this is a particular code to load. You just replace the paths, but while doing it, just be a bit careful about the train and test data. Let us load it. Keep on confirming parallelly if it is done, okay, so that we can move forward.
सर आपने कौन सा ट्रेन टेस्ट लिया हुआ है? एक्स वाई एक्स वाई.
Got the data? Loaded the data?
Loading.
सर अभी नहीं किया.
Yes, loaded.
Just check the data. It's about loan and loan approval.
Yes.
Let's check the describe.
Let others load the data first. I think we should wait.
I think we are almost at the end of the session. That's why I'm getting worried. But
It's time.
I have written the whole thing, and I'm telling you in advance, you will get a basically error over here. Try to understand why you're getting error over here. Okay. Then basically we are changing to overcome that error. We have done basically the label encoding.
Okay. It is saying that it cannot convert from string to float, right?
Yeah. And at the same time, they actually in the class I wanted to ask one more question, but I think now when we get the data, do you really think always all the data sets will be in the same scale? May not be, correct?
No.
Sometimes some revenue numbers will be in a very high numbers, whereas the people number will be in very small, correct? So that is the reason sometimes we have to do the scaling part. That is the logic. So these things we will discuss in details, but I want at least you to look into the various functions. So the function here used is mini scalar is a function that is used over here. Okay. So every function I have written. Hello.
Yep, I'm saying okay.
Okay. Similarly, label encoding function is written, but these are not the only function, because I within this pre-processing, you can see there are multiple functions are written. We have to see. This is 1, 2, 3, 4, 5, 6, 7, 8. So I wanted to kind of cover all, but I have just given the link to you now. Meanwhile, you can check, you can look into the logic for it. Correct.
Okay.
Some of them will be useful in some of the parts. And this, go through this whole case study. And I have given 2 examples of it. One is k-means, another is basically regression. So you will be able to understand from it. Similarly, this is another technique, one-hot encoding. I think we have discussed about the concept of one-hot encoding also before.
No, I don't think so.
Okay, this is the one thing, and keep it in. Please, I wanted to talk about this. This will take a bit time.
Okay.
No, hot encoding.
Okay, it's 4:31. We have passed the timeline.
See, one-hot encoding, just for quick understanding before hello comes. See, we get the data like this, right? Like red, yellow, green. These are 3 colors.
Yes, sir.
Now, if from row we are putting them as a column, as 101010. That technique is known as one hot encoding.
Okay, one hot.
Yeah, one hot
Okay.
encoding. It's create. You remember I have talked about creating dummy variables while R.
Yeah.
So the same technique. The name I'm actually talking about, the one hot encoding.
Okay. We do it in categorical variables.
Categorical variables. Yes. So how was the class today? Liked it?
Yep.
While others are doing it? Run this and try to understand this. If there is any question, ping me. Okay.
Okay.
Okay, sir.
Even in today's case study also, we have used some of the pre-processing technique. Please look into them. And today's case study we have done using SQL and PCA. If anybody is interested, probably try IPCA also there.
Okay.
So now we are good with the dimensional reduction concepts and the PCA concepts, at least.
Yes. Yes.
Everyone?
Yes, sir.
Yes, sir.
Okay. So keep on working on this. So basically the first case I'm just quickly telling meanwhile what. So what we are checking here, the various variables and to various different scales. So that is the reason sometimes we have to do the scaling. Because with scaling you will see in the K means you can write it, or K nearest neighbors classifier, KNN classifiers, you will see automatically the accuracy will increase. So you can take out one of the any of the algorithm, you can start doing this pre-processing, and you can see automatically in your output the accuracy of the data will go up. So that is a small thing I wanted to show it to you. Just go through this in this case study, then we'll discuss it later on. Okay.
Okay.
So on that note, wish all of you a very good week ahead.
Same to you.
And some of the things. So what I wanted to tell you is, any one of you has started looking into the various examples of which is given under sklearn, like the way we have looked into matplotlib. You can see these are the case studies. Another phase dataset case study.
Okay.
So here the technique they have used mini batch dictionary learning, mini batch PCA, fast ICA, NMF, SVD, and you can see
Interesting,
results.
sir.
So if you are more, see, in this case mini batch is not giving good results, but you can see mini batch K means.
Yes.
Yes, sir.
Sure. Thank you.
Thank you.